Well, that was it. I mean, we did 10 seconds where we did talk about LiDAR accuracy.
Yeah.
We are live is what we're being reported right now. And so if you guys are seeing this live, welcome to the live stream. We are still dealing with a couple of technical difficulties. So let me just verify that we are live. And can someone text me if we're live or not? We are?
Yeah, on Facebook, I have it open on my other screen.
Oh, okay.
Yeah.
Yes.
Well, hey, everybody.
Hi, welcome to the Drone Money Podcast. Another episode, and today we're actually going live on two different platforms. So the Facebook group, like we've been going live on, and we'll have some updates on that about the Facebook group here in a second. And we're also doing a second live stream on YouTube. So we will be live on the Indiana Drones channel. So if you're watching us from YouTube, Indiana Drones, welcome. We've been doing these live stream podcasts every other week on a Facebook group, and there's an awesome community of people over there talking about drones, surveying, mapping, and really it's all the offline chatter that's happening from Indiana Drones and ROCK Robotic. It's all kind of happening over there in this one ecosystem on Facebook. We started about 2 months ago now.
Yeah, the start of the year, pretty much.
Start of the year, and now it's over 6,000, right? We're
7,000,
7,000. Great,
50-ish. Yeah.
So that's been a really vibrant community. So welcome to our live streams. It's me, Harrison Knoll, Indiana Drones, and Daniel Wyndham here. And today we're going to be talking about LiDAR accuracy and all the things you want to know about LiDAR accuracy. And I think we're going to start out doing a little bit of a intro to LiDAR again for anyone that's new and just now getting into this. And then we'll bring on a guest speaker who is a licensed surveyor, and he'll be able to talk to us about LiDAR accuracy as well. So I think it's going to be a really vibrant conversation, lots of valuable information, good insights. If you guys are listening to this in your office, go ahead and just let it play in the background and learn a few things. And as always, if you have a question, just go ahead and comment, ask us a question, and we get to that at the end of the episode. So let's go ahead and get the show rolling. What's up, Daniel?
Oh, are we live?
Yeah, I think we're live.
Okay. I thought it was all.
That was all that we were prepping, so we're not live.
Okay.
Now we're live.
I should have listened closer. No, how you doing? What you been doing?
I'm good, man. I did a workshop with Dylan Gorman this weekend, and so Dylan Gorman, the other YouTuber, and it was pretty awesome. We got to train a team of newcomers into the drone space, and kind of covered everything from just drones in general to photogrammetry to LiDAR, and then we did a fly day. So we went out and flew. It was awesome.
That's awesome. What'd you fly?
We flew a P1 on the M300. Yeah. And we flew the R360 on the M300 and the Mavic 3 Enterprise.
Oh, sweet. That's a good setup. I feel like that covers pretty much everything.
Yeah, actually some really cool things we did. So we're using the new Mavic 3 Enterprise with the ROCK base. So and this was far away. So I have a node here at my house, and I had to drive, to this far away at Dublin. And one of the cool things that we did, I logged in to the RTK, and I was almost 40 kilometers away, super far from the base station. And it was funny because so Dylan had his Mavic 3 Enterprise out there on the ground, and he had the DRTK2 from DJI. Yeah. And so I pull up. He's already setting up. He's already had it all set up. He's trying to get connected to the DRTK2. And I'm like, I wonder. And so I pull out my M3 and I bust it out, and then I connect, get RTK fix. And then all this happens before he gets fixed. So he's already been set up, waiting for
the local base station.
His base station
right here.
Yeah, it's 2 feet from him. It's right there in front. And then really interesting, we looked at the residuals, so you can see like the northing, easting, and elevation, residuals, the accuracy of the algorithm tells you.
Right.
And the base that was all of 35, 40 kilometers away was more accurate than the base that was sitting right next to him.
Nice. I'm excited to do that. My base on my roof actually just got its precise point today.
Sweet.
So another node up on the ROCK base network. So I'm really excited about that.
Dan, we have some really interesting stuff happening with the ROCK base network, and sounds like everything is a go. So this is a little premature information. We'll launch this information maybe next week, but it sounds like we're going to be expanding up to like almost 3,000 nodes just in the course of the next month.
Is that a lot, Harrison? Is 3,000 nodes a lot?
Let's just say we just started this project 2 months ago, and I think the largest network ever made in the world is like 5,000 nodes.
Oh, okay. Good.
Yeah,
Good.
yeah, yeah. So
Huh.
we're already going to be breaching this 3,000 mark, and then I think it's going to just grow super fast. And like, why is this important to me? It's like one thing. Imagine you're like a utility or something. This is someone that we talked to. Actually, we had a utility come
I
out
did too.
to
Yeah.
meet with me. They're
Yeah.
actually a very well-known consultant firm that works for the utility.
Mm.
And what they want to do is all the GIS. So everyone that's out there doing any GIS work, any
Mhm.
inspector that's out there, anyone, exactly with your phone, anyone
Mhm.
that's using a drone, everyone who's doing any sort of geospatial data capture to be on that same base network. Such way,
Yeah.
everything is going to be RTK accurate on that same coordinate system. So
Yeah.
it's like the Rock base can form this coordinate system for you of just
Mm.
leveraging. I don't know. I'm pretty stoked at that kind of application.
Yeah, that's awesome. And talk about the one thing that I really like is a consistent workflow. Whether you're a company of 2 people or 20,000 people, you don't want to have to learn how to do the same thing like 8 different ways.
Yeah.
So, if you're just able to reduce all that friction in your organization, that's worth more than anything you can buy, because the time you're taking and the effort you're putting in and the coordination, and not to mention you're paying for it. I mean, it's $1,500 for one of these a year in Georgia, and I might have 20 of them.
Hmm.
Not to mention drones and all that kind of stuff. So and being able to control it. I mean, I want it near where I am. I
Right.
don't care that the state put one 15 miles away if I never go to that town.
Yeah.
Like I want one here, and I can
Totally.
put one here. And so I literally have one on my roof now.
Yeah. Yeah. The other thing is, like, even when you go out to the field with your MLID or your DRTK2,
Mhm.
like, even if you're doing RTK and you set up that base station and
Mm.
then you have your rover, which is the drone flying,
Mhm.
the accuracy between the two is RTK accurate. So you have precise data, everything's precise to, 1 to 2 centimeters. But the base station still isn't surveyed in. So you still need to get an Opus solution or set it up on top of a monument or some sort of benchmark,
Right.
so to tie the base in. So then this whole thing, because the whole thing can drift around, right, up
Exactly.
up to the accuracy of a single GPS. And so the
Mhm.
idea is that that step always has to happen whenever you go out to the field with a
Mhm.
base station. You always have to tie that thing in, and either you're going to do a 2 hour plus collection and do a NRCan or Opus solution on that, or you're going to set up over a known point. Either way, there's a big workflow you still have to do. But with the
Yeah.
Rock base, like you just said, that thing just got surveyed in by Rock, and well, not surveyed in. I don't think we can say that word, but we
Yeah.
performed mathematical
Measured.
calculations to
Measured.
determine the location.
Yeah. Well,
Um,
I talked to one group. It was a utility covering an entire state in the United States, and they were planning on spending 2 hours per day per scan to run an Opus solution for the next 3 years.
yeah, that's a lot of time.
And then now it's going to take 10 seconds on the Rock base.
Yeah,
I mean,
that's too much
you
time.
just can't beat it.
Well, change of news. I got this cool mug. It says Rock on.
I have one that says Rock Robotic.
I had that one. Then I
You
moved.
go.
I don't know where I
Thank you
put
for this.
it. Yeah. So let's get talking a little bit about LiDAR and LiDAR accuracy. So I think
Yeah.
that's this topic we're here to talk to you guys today about. And actually, sorry, I'm gonna actually detract from that. We'll get to that in like 2 seconds. I want to say one more thing,
Mhm.
and that is so yesterday I put out a forum and a form, not a forum.
Form. Yeah.
And basically, so what Daniel, myself, and a team of about 5 other people, so with the Indiana Drones team, with the
Mhm.
Rock team, we're working to build out a lot more training material and put it out there on the internet. And
Yep.
so, like, basically, it's not enough just to know how to use a tool. That tool exists inside of a framework, which is a business. So either you're, a self entrepreneur or you're working inside of a company. And so all of this knowledge that you need to gain in order to be successful using this technology, not just the actual joysticks, but the data, the bidding of a job, like all of this stuff, the control we're talking about, all of
Mm.
these things are what we want to teach. And we actually want to hear from you. And so we want to know, what do you want to know? So I
Yeah.
made a form, has one question on it. What do you want to know? And so I think if someone can put that in the comments, we'll go ahead and post it several times in locations to find it. You will find it. I would love to hear your feedback because it's going to guide us in what we're going to make over the next 3 to 6 months. And there's going to be a lot of content that we want to make. I think this, Daniel, you said it the other day really well, and I really like this. There's a new job that's coming out. This drone field chief, right? Party chief,
Yeah.
drone
party chief. Yeah.
Yeah. And so, can you explain to me what a party chief is?
Yeah, so in land surveying, you usually have more than one person working at a time. So a party chief comes from a long time ago, and Seth will be able to help us with this. It used to be 20 people in a surveying party to go out there, back in 1800s or even early 1900s. And as technology has increased, the number of people has gone down, and a lot of places even just have one person. But if you have two people, usually there's one guy in charge who's the party chief. Or two or three people. And then there's instrument operators, or you might call rod man or something like that. It's just, you've got the experienced person. They're the one in charge. They're the party chief. And then you have other people who are up and coming, almost an apprentice level, learning the profession. And so what we've got now that I'm seeing is in surveying and in just geospatial data collection. I've seen it for, large industrial companies, even that just have lots of facilities. So it's basically a surveying knowledge background job that needs to be able to fly drones all the time, and is an internal drone company. Or at a surveying firm, they might run the drone program because they don't have the time or the knowledge to start the program themselves. And so I kind of did this. I didn't have this title, but I got hired by a surveying firm to start a survey drone program. And then they said, just go figure it all out. And so, of course, that brought us together. But that job is leading the geospatial collection with drones and other similar things in a surveying workflow.
Right. So I think there's the drone party chief is we're going to start saying that word a lot. As long as we keep using that terminology to reflect the ability to either run a drone program within a surveying firm or to be a DSP, drone service provider. And that is all the services and kind of the operation. So it's basically either it's the business within the business or it's the business all in itself.
Right.
And so that's really, I think, what we've been talking about. We want to teach to that. Let's train that skill so everything from ground control points, photogrammetry, which drones to fly, LiDAR accuracy. We'll talk about that a little bit more today. Pitching your how to scope out a job. How to deal with the FAA. All of these different nuanced into running this program or being your own business, running the program. That's really what we're going to get at. So we want you guys to also help us feedback. We know a lot, but we've got blind spots of things that you want to know that we don't know you want to know. There's a form. Fill out the form. Let us know what you want to know. Then we'll know what you want to know. Then we'll teach you what you want to know. Then we'll all know.
I do know. Can you just say it one more time?
No.
Yeah. See, now you said a different one.
Okay. So, I think let's get off the soapbox and start talking a little bit more about LiDAR accuracy. And
I got shorter. I'm off my soapbox. All right.
I think honestly, let's go ahead and bring Seth on
right
now.
Come on,
Seth. He's a great knowledge, great resource of information. So Seth from Bowman Engineering, is that the
Bowman Consulting?
Welcome to the Drone Money podcast today. So nice for you to join us, and we know that you've had a tremendous career in surveying and then getting into drones and LiDAR and all the above. And you just heard us rant about a position that you probably are doing and or have other people helping you do.
We got some people kind of in that role, I guess. I don't know if we're calling it that term exactly, but very similar like that. It's just the way the industry moves. So thanks for having me on here, Harrison. I don't think we've ever really talked too much. Daniel, me and him are always sending something back and forth on LinkedIn or Facebook or something.
I just like all your kids' photos. It's
I do the same thing for you, so it's a two-way street.
Yeah,
I think we said all of 5 words before we went live here a couple seconds ago, but it's an absolute pleasure, man, to have you here sharing some knowledge with the whole community. I think everyone listening today and watching this in the future is going to get a lot of information from this podcast. So would you mind sharing with us a little bit about your background, how you got to where you are today, and where are you today? And
of course. So I got into surveying. I went to college for it. I have a bachelor's in surveying engineering from Penn State University. I'm
awesome.
Pennsylvania country, back roads, born and raised. I think that's why I fell in love with the surveying side of things.
Yeah.
All of us are like growing up in the woods. Not to cut you off, but like I feel like we all have that in common.
We were just talking about killing snakes before this.
Yeah,
a few. Yeah.
Yeah.
Yeah. I think that's a common thing that you see with surveyors across the board everywhere. At the very base of it is a love for the outdoors. You like being out there. I wanted to be an engineer, but I didn't want to wear a tie every day. That didn't sound like too much fun. So yeah, I going to college, jumped around a bunch of internships. I wanted to work everywhere I could, learn from as many different people. And pretty early on, I was like in the LiDAR side of things, doing terrestrial scanning and everything. Bowman, I've been at since 2016. I actually came in as an intern. And they were crazy enough to keep me around after college. But I thought I walked away the winner. I ended up down in Florida at an office with a great group of people down there, and they had a drone sitting in a box that really wasn't being flown. Asked some questions about it, so we decided to, I was the young kid in the office that was willing to take it under his wing and figuratively and learn how to fly and get going with it. So started doing photogrammetry mapping. Did plenty of photogrammetry in college, so I had a good base to start off of from that. And it's really grown. Now it's a national program for Bowman. We have 20 plus pilots. We have over 30 drones. We're flying in a couple states every day, it seems like. So whole group with it, and I pretty much went from being a survey intern to now I'm the UAS Program Manager. That's what I oversee and do. All of our pilots and drones, keeping all those standards, making sure we're doing everything as best we can, and keeping that accuracy. So
that's awesome, Seth. So can you tell me a little bit more? So let's back up before we jump into everything we're talking about today. I think there's a couple of questions for the audience that they'd love to hear you talk about a little bit more. So I see here behind your name, you have these 3 letters, PSM.
Professional Surveyor and Mapper. Yeah, so I'm licensed in the state of Florida for surveying. I got that just a couple of years ago now. So
how is this different from any other licensure that you can get for surveying?
Every state has their own specific requirements, and with that, a lot of them have different acronyms that they use for it. The most common being the PLS, Professional Land Surveyor, and for Florida, it's a PSM, Professional Surveyor and Mapper. So with that, actually, especially for the state of Florida, a lot of the aerial mapping stuff and the drone stuff, naturally, a lot of that does fall under the realm of a surveyor and needing to be overseen by a licensed surveyor. And it's a professional liability that we take on for this type of work, to say that what we're giving you is the best data we can give you.
So kind of in that, so I know a lot of people watching are not a PSM, and this is a very common question. So could you take data, like if you sent someone out to the field to fly for you, can you take that data and then use it in your survey?
So again, that's we're in like that political gray area, right? Every state's a little different with it. The way Florida has it in their statutes and regulations is whatever data you're using and you're signing off on needs to be under your direct supervision. So, and there's a couple different ways people try to interpret that. I'm on the strict side of it. They need to be directly working for the same company as me in order for me to be using that. So I don't have to be the one out flying the projects, but it needs to be somebody who works at my company doing that for me. There's plenty of ways to get employed with those types of companies that are doing that type of work.
Well, it sounds like you were an intern before all this, and now look at you now. So that's awesome.
Yeah. So it's the technology. Sky's the limit for anybody out there that wants to get involved in this stuff. So I like to think I'm a good example of that.
Is that a pun?
It's real fun.
Put that upon the sky's the limit.
Yeah, well,
I like
just take credit for it. Yeah,
I'll take credit for that one. Yeah, that was me.
Yeah, good one. So let's have a good discussion about LiDAR and LiDAR accuracy. So I think, first I'm going to bring it at the beginning and just kind of describe LiDAR in general. I think whenever we're saying LiDAR, we're referring to a specific type of LiDAR, not all LiDAR. Although there's many different types of laser scanners out there, terrestrial ones, mobile mapping. I think we're probably going to we can talk about all those, and they all kind of fall in the same category or similar categories and how you test the accuracy. But we're going to talk about a little bit more like aerial LiDAR, so drone-based LiDAR.
Yeah.
And then we can also talk, show how it extends out to these other modalities as well. But on the drone-based LiDAR, we're talking about a system that's flown on a drone. It's conventionally in the past been flown on an airplane. These are devices that are shooting out, hundreds, if not millions of laser pulses a second, capturing distances and then geo-referencing those distances to locations on the ground by the use of GPS technology as well as IMUs. So IMUs to find your orientation, GPS to find your XYZ location, and then the laser scanner itself is finding a distance. And so it's all projecting this, taking this data together and projecting on the ground. So there's a lot of sources of error in these systems. There's a lot of ways to verify and validate data from using other technologies, and then using that accuracy to look at this accuracy and make an assessment of this one. So I think let's have a nice conversation about just in general LiDAR. So I think that's LiDAR, but let's talk a little about LiDAR accuracy. And I don't know, Seth, do you want to jump in and just maybe describe to us a typical job, and then talk about how you use LiDAR in that job, and then we can kind of go from there to how then you would get accuracy. And then I don't know, does that sound like is that a good way to
we could
broach the topic?
We could talk through a hypothetical project. I guess that's what you're getting at, right?
Yeah. Hypotheticals, and then we'll kind of go from A to Z, kind of walk people through the process and kind of maybe explain it as we go.
Yeah. So let's come up with the hypothetical. So for me, my company, we're in the land development business. We do a lot of land development and everything. So on the surveying side, we go to a lot of sites that are just, they're woods, they're a pasture, the field, whatever. So those are really where LiDAR shines in my book. When you have that vegetation, you got to get through that. So LiDAR is a light beam. Light beams are really tiny. There's my hand, real tiny.
Yeah.
So I always tell, when I'm talking through with a client or somebody learning about this, if you can walk into the woods, you look up and you see the sky poking through, your LiDAR is going to poke through. It's going to find its way through if this sunlight can. So 20-acre site, 50 acres, 100, can go up from there. Really.
I love it. So I'm getting an image in my head. So we got this, I got this 100-acre site. We got some trees, there's woods, there's a pasture, there's a red barn over there somewhere,
Okay, red barn. I like that one. That's a good
roof falling in on one side.
Yep. So there's
you know this place, Daniel.
I've been to a few.
The crocodile, he's just hanging out right in the middle.
Yeah.
You can't see him.
Yeah, exactly.
Yeah. So we got this site, and no one wants to walk that thing.
No.
Now we want to use LiDAR to go and because I think walking, this sounds dangerous, especially with that crocodile in the middle, right?
As long as nobody's fed them before, you should be fine. Rule of thumb there.
And then now we're doing a land development project. So what would they do? Yeah, what were you looking for here?
So you think about 100 acres. That's going to take a long time to walk through and survey normally. So we're going to look at that and kind of look at that whole site as a whole. Google Earth's our best friend for this stuff, right? And from there, we're going to kind of think about we're going to use our LiDAR to scan it. We're going to hopefully get some sort of topographic deliverable. We're going to get the contours so they know where elevations are. They can, engineers can do whatever that weird math is that they do and come up with how they want to design this site. So your first considerations are how are you going to fly it and how are you going to control it.
Mhm.
So how you fly it is going to help make sure is going to help you succeed, that all your data that you collect agrees with itself. It's all relative to
Mhm.
itself. And then the control is going to help make sure you're accurate and relative to the state plane coordinates that you're in.
Mhm.
Pretty much everybody works in state plane coordinates anymore. It's the beauty of GPS. I know you guys have we're talking about your ROCK cores stations you're doing and everything, which awesome, by the way. I've been keeping an eye out for when I can start downloading some RhinoX files off it. So
Absolutely.
Working on it. Yeah.
So
we all want to be in that state plane. So this is yeah. So basically, you're talking about mission planning and then laying that control to tie everything in to that final deliverable, which is in that state plane.
Yeah, whether you're setting that or some other surveyor setting it, or for you or something, and the real one of the big make it or break it is how are you going to locate those control points on your site. So you guys were talking about using your virtual reference network, your ROCK cores, the ROCK network to get coordinates on all of these. Just because you collect coordinates doesn't mean they're great coordinates. You have to think of, especially GPS, how long are you sitting there? How many satellites do you have? If I'm up against a tree, it's not going to be very accurate.
You can say that one more time, Seth, for everybody setting up their base station.
Yeah. Don't put it next to a tree. I know you like the shade, but stay away. Right. Yeah. So, and from there, it's a trickle down effect. Every step along the way, you're gaining error in some way on this project. You're setting control. You got to check it back against other points. You got to be getting some ground shots or doing something to make sure and say, hey, look, I know my data is good. I've checked it against this. We did all these extra shots through this field. We walked 2 lines down that whole field, collecting points every 50 feet or something, to check against. So all of that.
I'm going to go ahead and I just added this. So I have a box here. I'm just started drawing on slides here. So I got this. Man. Here we go. I got this 100 acres. And here we got let's go ahead and throw here's my barn right here. There we go.
Gonna have like a state highway out front, right, Seth? And then maybe like a county road.
You're describing every site in Georgia I've ever looked at, Daniel.
Yeah, they all, basically. After the 3rd or 4th, 100th one, they all look the same.
Yeah, here's our county road right there.
Yeah, because you want to have that back entrance for your fire department.
Yep, fill that in. And okay, so let's just say this is, and then I don't know, let me draw a little weird area. I don't know, I'm going to use this, one of these things. This is all trees. That's the back of the farm. That's not where they don't do anything over here yet. So we're talking about planning this mission and setting up some control, I guess. So if we got this parking lot, maybe this is too literal.
Our pond.
You're really getting into this, Harrison.
Our fictitious thing has become very literal.
Yeah.
But no, this is great. Having a visual like this, it's great.
Yeah.
Yeah, this is our parking lot driveway. This is where we park when we come here. And then
Harrison's going to name this place by the end, and we're not going to develop it, Seth.
This is my development. We call this Shady Acres.
Yeah, Shady Acres. Rock Ranch.
So I think you're talking about, you would go out and capture. So you talked about getting a bunch of ground shots, manually. And so I'm going to just create some of those, call them triangles. It's a huge triangle.
And Seth, when you're doing these, even on LiDAR, are you doing photogrammetry and LiDAR on these types of jobs?
Yeah, just about every site we fly LiDAR on, I'm flying photogrammetry as well.
Right.
We do separate sites. So my company, we have systems from LiDAR USA, and we opted without the cameras, and we just do a separate flight. Sometimes on the bigger sites, it's nice because we could throw up a fixed wing to collect our imagery and everything. So that's partly why. And when we bought our first system back in 2018, there really weren't options to have cameras on them.
Yeah.
So
yeah, that's right. So the technology changes quick.
Yeah, it's a good example of how it can change.
Yeah. All right, so I got put a pond right here, guys. This is the lake.
I'm gonna frame this and send it to you as a 24x36 when we're done with this.
This is trees. So I made a bunch of these triangles here. I'm just calling these are check shots on 100 acres. So what we're talking about is we want to be able to first capture good data. And before we're going to do that, you want to set up this control. And so we're going to set up some aerial targets as where I think we're going to get to. But, you know, in 100 acres, how many of these triangles, how many shots are you going to go to get to verify your LiDAR data off of?
So I think we need to first, how many control points do you want on your site, right?
Yeah, we get that question a lot, Seth. What do you think?
So I phrase it to everybody. Same with photogrammetry. It's like you have a blanket with a bunch of ripples in it. It's kind of all wavy and everything. Your control points are like tacks. You're sticking that thing on the wall, on the floor, whatever, wherever you're putting it. But that's how you're tying it down, and you're kind of flattening it out and everything. So the basic answer is you do your four corners and you do a point in the middle.
Yeah. I usually do some sort of paper or my Atlanta Braves World Champion stickers I still haven't put on my car. You know, if you don't have anything in the middle, you could be right on the corners, but what are you going to do? Yeah,
exactly. So I personally like I kind of like doing a line, you know, if I say on this one I'm flying east to west, I'm going to do some control points on the left because it's the start of some flight lines. I'm going to do some all the way on the right because they're the end of flight lines, but I'm going to put some right down the middle, right up the middle there, a couple of them, to, again, make sure there's no bubbling or lift going on, elevation issues, and also just elevation issues, make sure it's all agreeing with each other. Oh, are you putting some flight lines in now or something?
Oh, yeah, baby. I'm putting flight lines in. I don't know why
we get excited. Okay, that's why we have this group. That's why we have these events, right? We have to let this out somehow. We got 7,000 people that love this stuff too. So
if I don't get
absolutely. So this is a great example. I mean, I'm going to plan my flights, do that flight planning, that first step, and then I'm gonna make sure I have control smack dab under some of those flight lines.
Okay.
So my LiDAR is going to hit right down at a nice perpendicular angle. I'm going to see those targets real good.
Mm-hmm.
So you are saying, so basically we want this shot. We want this to be right under that line.
Yeah, and then I'll probably do another one on like the next line up or something, you know.
So you want another one up here.
And Seth, when you're doing your flight, can you talk about in the workflow? So when you're setting these GCPs, how do you, I guess you're already doing the flight plan and knowing where they're going to be. Do they have stake points out there? Like how do they go set these control points and know they're under the flight line?
Yeah, so we give them, I'll give them approximate staked points to use. So it'll be in a CSV or something.
Yeah.
Global Mapper is my best friend for that.
Okay. So you're just going in there and saying, okay, here's my flight lines. I'll give you a stake point out in the field, and you're going to get close to it, find a suitable location within a few feet.
Yeah, and then I'll give it to them in a Google Earth too, so they can pull it up on their phone. In the past, I've given them my flight lines to put in their data collectors and overlay right there. So then if they need to move them a little bit, they kind of can see. It's a great way to do it for field crews. So, and then larger sites, what I tend to have us do is base rover with our GPS. It's a little too big to get around with a total station. Base rover tends to give you a little bit better residuals than just using VRS and you're using a couple cell towers somewhere real far away. It's kind of the easy way out, I guess you could say. So a little legend going on there. I like that.
You gotta have a legend in the north area, or it's not a map.
That's right. So
now, because you're here, can I claim that I'm working underneath you so that way I can make this map right now?
Yeah.
I think we're gonna need to add a few extra things on there. So
this is actually
really an NFT. I don't know where this is. It still looks like most of Georgia to me.
Well, hey, North Florida too. Okay, they look exactly.
You got me there. North Florida,
not Central.
No.
So like Seth, when you're running through these jobs, like like we're talking about here, you're setting up your flight lines, you're getting your control set. One thing, and I'm interested in you do this. One thing I like to go shoot is if there's any similar looking road paint out front, especially if there's a highway with a turn lane, like the tip of the arrow or something like that. If even the edge of the sidewalk, something with that intensity view looks different. Can you talk about how you identify features in the LiDAR, like the GCPs or other things you might capture?
Yeah, so I love using paint stripes. If I could use a turn arrow or something, or a corner of a stop bar, we're going to use them instead of putting something else down.
Right.
So you have to remember you're working with light and it's reflecting back. So you get this intensity value to it. With the intensity value, certain surfaces don't reflect back as well. A smooth, shiny surface is going to reflect back better than fresh black asphalt, like Harrison's parking lot that he drew in there.
Sometimes they barely bounce back at all if they're new enough.
Yeah. So, and depending on what system you're using, sometimes intensity shows up is not as good as on other systems. This right here shows that intensity pretty good with those paint lines there, right? So what may look obviously different to you from an image standpoint might not show up well from a LiDAR standpoint is what I'm getting at, because you have to think of how it's going to reflect back.
Yeah,
so light surfaces, dark surfaces. So
I'm scrambling here, Seth. I'm getting examples as you're talking for people.
Yeah,
this is the intensity.
Keeping you on your toes today is what I'm doing.
I'm going quick.
So when going through the workflow again, so you're going and setting up control. You're understanding where you're going to fly. You're setting up stuff there. You're using the natural environment or the man-made environment, whatever you want to say, to save you a little effort and get you some more data. So now you've captured the data, and you're using base rover, whether you're using VRS or whatever it is. So now you're ready to go fly. You've flown the mission, and now we're like looking at Harrison in the data here in ROCK Cloud of this data set. So when you've got the data set, how are you checking your control that you've captured according to your plan versus your captured data?
So a good thing, even though you're adjusting your data to your control, you should still check your data to your control, if that makes sense.
Yeah.
Because
so some points you're moving it to, but then you want to have some points I'm not doing any interference with those points in the data, and those ones are going to be checked later.
Yeah, and it kind of lets you know if you're doing, you have your passes aligned up real well, and then you're checking back to your control, and you've picked your control points, but sometimes that doesn't mean you're right on those control points, because your LiDAR data also wants to be relative to itself. It wants to have that precision to itself. That relative accuracy is the word I always see a lot of people use, which is just another way of saying precision.
Right.
So to me, if I check back to my control with what I think is my final point cloud, it gives me a good understanding of just how well my data adjusted to my control. There's a lot of things that can cause inaccuracies, and some of them can't be eliminated through picking control. There's because you have, if you want to really dive into what causes an error, there's three types. There's the systematic errors that you can reduce or eliminate. you have random errors that crop up and you don't really know where or how, but they come up. That could be noise in your scanner as you're going. You don't quite know where the noise is going to be, but you kind of have an idea to it. And then there's just the blunders. You messed up. In the surveying world, it's you're writing down a coordinate and you swap two numbers around or something. That's a blunder. It's an unintentional mistake. So checking your LiDAR data back to your control is a good way to see if you've reduced your systematic errors, and if you have any random errors in there that you may have to worry about, whether it be with your trajectory or maybe just some of the grass, some of the points you didn't quite pick too well, something like that. That's systematic. You can go back and fix to try to tighten it up. And then the next step is I'm going to look at those other points. Like you had some there on the runway, Harrison, where they're just pretty much points equally spaced out across.
Yep.
That's a great way to tell me going in that direction in that area. How good is my data compared to these points I'm checking to?
Yep.
So.
Yeah, I think so. Like one key thing that you just said there that people should pick up on is that, you were talking about, at one point I moved the data set to that point, but I actually didn't move it to every point. I just looked at this one. Now I'm going to go and look at all these other points that I didn't do any sort of adjustment from the data set to those points. But now I can just look, and see, are all those points lined up nicely with the data set? And then now that would tell me the accuracy, not just the precision, because we only used one in our alignment process. These other 100 points over here that I got, I'm just using those to check and, sanity check that the rest of the data set is now accurate.
Yep. Yeah. It's, you have your dependent checks, the ones that you've used in your adjustment, and your independent checks. If you're going to work for a surveyor, they want those independent checks. They want to know that it's reliable to, is it reliable to 1/10 of a foot, 1/1500ths, 2/10 of a foot? Is it better than 1/10 of a foot? That's what they want to know. So that people know how to interpret those contours and everything that they're looking at.
So let's come back to our 100-acre example here. So in this one, we threw the corners and we had the plus signs, the control, and these would be used in any sort of movement of the data. So this is like the data sets being controlled and tied to these points. And then I drew these triangles. So say 100 acres, I have, 6 control points. Does that sound reasonable? Obviously, we're going to use a bunch of.
Yeah, six control points could work on a 100-acre site, right?
Yep, I think so. And then we got these. So how many check shots would you want to see? And let's distribute these a little bit better. So I just kind of threw them out here.
If you want the surveyor answer out of me, I need a minimum of 26 checkpoints.
I love it.
And that's so I can actually have a proper sample data set to calculate a 95% confidence interval. But that probably just went over people's heads. But the more check shots, the better. Is the way I phrase it. And a variety, have them across your site and in a variety of areas. On that road is great. Have some in the grass too. So I have like a vegetated and a non-vegetated.
Exactly.
And that's really coming right out of ASPRS standards, which is pretty much the industry standards for this type of work. I encourage everybody to read through their stuff, which they have new standards that they're going to be releasing later this year. So everybody keep your eyes open.
How do we get on? So I know someone that's been asked to review some of those standards. I think if you know anyone, Indiana Drones over here wants to talk to some people too.
I was asked to review them. I have not yet. I have a few more weeks, I think, until the period closes.
I'll have everyone out there listening right now. I was not selected by anyone. No one likes me.
Are you taking this personal?
I am because actually we did some project up with Dewberry up in Alaska for the FAA, and it was with Dave Mowney, and so he's one of the guys that wrote the 3-depth regulations. So he's like the head guy.
Yeah.
I don't know. I just think I like Dave. Dave's an amazing man. He wrote a great book called about DEMs. Love the book. I just think they think I'm too young, and obviously, physicists can't know anything about surveying.
Hey, I get the young thing. That happens to me too. Don't beat yourself up over it. But the physicist thing, you're on your own. You're on your own for being a physicist.
I am on my own. Yeah. No, I just I would love to. So for me, the things about accuracy. So one thing is like these standards you're talking about, these ASPRS standards. Kind of the minimum area right now is 500 square kilometers, right? And this is just massive. Like ain't nobody doing that with a drone. So you're instantly, it doesn't even apply to you. And then they don't really have like I think there's good standards when it comes to digital data products.
But even those were even written in 2014, when a lot of firms were just switching away from film cameras fully for manned aircraft. So it's
film cameras.
It is a little bit of a catch-up game that they're playing, but it's a fast-growing field. So I'm optimistic.
I'm optimistic. I hope they integrate. I hope they talk to DJI. I hope they talk to Drone Deploy. I hope they talk to Pix4D. I hope they talk to ROCK. I hope they just talk to the players that are actually producing the data for people, because we're building the equipment that the surveyors use. It's like we should have some input into, because we're building the systems, and it's like, for instance, I one of my friends, so TopCon, so TopNet, their VRS network.
Yep, I've used it many times.
So he wrote that entire system from line code 1. So he's the guy who wrote it, conceived of it. No one's ever asked him about accuracy. And I'm like, you're the man who actually made all this stuff. And same thing with the people that make the GNSS receivers, like the hardcore RTK algorithms that are running inside these things.
Yep.
I think these people really need to be brought into the equation. And I know a lot of them, and I'd love to. If anyone in the surveying community is out there listening, I'm just saying it's a wide open door on our end. I'd love to talk about it. So,
yeah, right. I'm right there with you. I love taking the deep dive on that. I'll talk whatever I need to on it. Least squares adjustment, chi-square test, whatever I need to talk about. Just sign me up. We'll get a little in depth here.
And I think the 95th percentile stuff is important for people to understand as well. So Seth basically gave a number of check shots in order to get a statistically significant result in his data. So at the end of the day, he's going to get a number. That number is going to talk about the accuracy of his data product. And how do you know if that number, so just in basic layman's terms, like if I just took one measurement, I have an N of 1, can I trust that exists across the entire data set? I think intuitively we all understand no. Doesn't feel really good. But then if I took an infinite number and I literally every single spot there is to be a spot and checked, and then I found out that all of them were under a centimeter, well, I think I'd feel pretty damn confident that it's all under a centimeter, because I tested everywhere.
Of course. And the number 26 seems like it's pulled out of thin air, but using N-1 brings you to 25.
Mm-hmm.
And the whole point of a 95% confidence interval is you're giving yourself a 5% chance that you might be outside that threshold because of one of your errors, whether it be a blunder or a systematic error in an area that you missed or couldn't correct. That's a large enough data set that you're allowed to remove, a really, one on either end almost, really, to help you dial that in to find a better accuracy for yourself and state confidently where you're at.
But you must listen to Seth and don't put them all on the pavement. You got to go in that grass too.
Yeah, I need to see some across the site. Yeah, I'm not letting you off the hook on this, Harrison. Make sure you walk it all.
Yeah, exactly. There's an alligator out there in the middle of the pond, Seth.
You're fine. He's not that hungry.
I did a map one time at a mining site in Middle Georgia, and it was for a photogrammetry annual report. Map, and then it has all the ponds across it. And then I got back and I processed it, and I was using Drone Deploy at the time, and so I zoomed in. I ended up counting 9 alligators, and they were all around me. And I was just on this little part of land. I didn't get super close to them, but they were there. So it does actually happen.
I have a mobile data set down in the Everglades, driving along a levee, and there's gators on either side in the point cloud I'm picking up. It's
Florida surveyors are like, what do you mean, my pet? Like, what do you an alligator? Who cares?
All right, guys. So I think we got I have some more questions. I don't think we covered the topic in detail. So we have some audience questions. And I'm going to go ahead and
lead the topic fully. Do we get a part 2 then in 2 weeks? Is that how
I think we're going to have to do a part 2. I'm going to ask a question that's very leading here because it's going to be I'm going to be the first audience question. Just what should an aerial target look like in LiDAR data if you're making it yourself? So we talked about paint stripes. We talked about some existing features that we can just leverage because they're out there in the wild nature of roads. But what if you were to make one yourself, Seth? What's the best practice you found in your experience of how do you make a aerial target for LiDAR data?
So, to me, it's all the size of the target matters because your point spacing, point density, you want to make sure you can see it well and you can pick wherever you're locating on it. So, flying a drone, I usually go with I want to see it like a 4 foot by 4 foot square, really. Mm-hmm. And then whether you buy them off Amazon or buy them from the local survey supply store, whatever, or you can make them, paint them. I've painted them on plywood. Just do a black and white checker. So black, white, alternating. And then where those 4 1 foot by 1 foot squares meet in the center, that's where you're going to locate. The black and the white, because they're 2 totally different colors, so you're going to get good reflecting on the white, not so good on the black, and it's going to help you find the kind of the center of that whole square. Yep.
How do you feel about squares versus triangles?
Either work. Doesn't matter to me.
Yeah.
But don't do this for LiDAR.
That's a little hard to get. When you have it in the center of lines like that, it could be hard to see.
Yeah.
Sure.
All right. Well, that was my first question. Let's go ahead and open it up. I'm going to stop sharing that. Let's open it up to some questions from the audience. Question: do you have an error checklist for each job, or is it all memorized in your head at this point?
I'd say it's all in my head, and then I've ingrained it in the heads of my coworkers of the different things to do. No, we do have some written procedures for in the field to make sure our data is, getting collected good. Our control points are, placed where we want them and how we want them located. Make sure that they're picking the right point on that turn arrow. They're doing multiple GPS shots on those points and everything. I think that's kind of where we need that part 2 to dive into that a little more.
Yeah, like your standard work procedure.
Yeah. Maybe we'll make a mock checklist for going out to fly that site of yours of what we need to watch out for.
Yeah, can we just build the whole field packet for the Alta too?
It's sure looking that way, right?
All the flats. Yeah.
All right, let's go to the next question. How can data errors trickle through your entire project?
So you always have error in your data. There's no perfect measurement. It's a matter of how much can you eliminate it. Talking those ASPRS standards, again, they're nice. The way that they phrase it is you take your accuracy of your control, whatever those residuals are of your GPS, when you're taking those points. Your final accuracy is probably going to be 1 to 2 times that horizontally and 2 to 3 times that vertically. Something like that is typically what they go off of, because it trickles down, but it can also be magnified from those early on stages.
That's saying that if on those your GCP shots, so it would be 2 to 3 times, and then I think it's like 1.4 times in one direction and whatever. 2 to 3 times, but that's if the data product that you're generating from the aerial remote sensing matches everywhere there. So obviously, if your aerial product is not matching anywhere, then the accuracy is going to be worse. So he's saying, given the fact that my aerial data product is perfectly aligned with my GCPs, and now we're going to take the next maximum error in the list. So we've minimized this error, but now we have this next one, which is the GCP error now, and those ones are only so accurate, and that's your residuals on that.
When you're adjusting to your control points, it's called a best fit.
Yep.
It's called that for a reason. It's not going to be perfect.
Do your best.
Yeah.
All right. Do you place targets for your check shots as well, or just for GCPs?
So sometimes I will for some of them. I might not for all of them, but like we talked about having 6 control points for that. Well, I may have the crew lay out another 4 or 5 of them, maybe to fill in some gaps, or, extra ones on each of the edge lines, kind of at the midpoints or something. Mm-hmm. And those will be like those could be those checks for me where I have that target out, and that's to help me check horizontally.
Yeah.
We talk a lot about vertical, but horizontal matters too and can also be off. So it is good if you can to have a couple targets out that you can also visually see and check that against.
Awesome. Totally agree. Is there an optimal flight ceiling when shooting LiDAR?
Ooh, this is very specific to a system.
Yeah, it really depends.
Yeah, so you guys have your 2 different ROCK Robotic systems, and you're going to fly them differently. My company has 3 different LiDAR systems, and they all get flown a little bit differently. So it all depends really, and that's a consideration to think about when you're going to purchase a system.
Mm-hmm. Totally. Like some systems can shoot much further range of the LiDAR, and then it gets into a lot of things with the IMU, the actual beam divergence of the laser beam itself.
I love bringing up beam divergence to people when talking LiDAR, because some people have no idea or never even think about that. I'm like, that's how you get through the vegetation.
Yep. Yeah, and also it's how you can get a lot of air.
Yeah.
And I like some people that will claim better accuracies than the beam divergence would even support. And doesn't pass the smell test.
If you have a high beam divergence and you're flying at a high ceiling, that's a pretty big point kind of hitting the ground. This is exaggerating it. So it might not be fully hit. You're going to get a partial hit and a partial return, and that's not as accurate. So
totally. I think I'm going to talk a little bit about that for a second. So that's one of the reasons whenever you're doing your overlap, and we're talking about because some of these LiDAR scanners have a full 360-degree field of view, so it spins all the way around. And then in post, what we're going to do is we're going to reduce that field of view such that we're only getting certain spots on the ground. So basically, if I'm flying down, I don't want to shoot a shot basically almost horizontal with the horizon. So if you think about a flashlight, if I'm shining a flashlight square onto the wall, that circle will just be a circle on the wall. But then if I shine a flashlight kind of along my table here, that circle will then spread out across the whole table. And so that's the beam footprint that you're going to get on the ground. And that reflected light's going to come back, and it's only going to measure one distance. But where did that distance come from? Because the light hit so many spots on the ground here. And so what we want to do is we'll reduce that field of view such that we're essentially reducing the footprint size on the ground, and we're constraining the ground footprint in order to say, I only want to have basically flashlight shots that are essentially a circle on the wall, maybe a little bit off circle. But I definitely don't want to have these glancing angles that are going to make a footprint that's a mile long. So that's a huge thing when no matter what LiDAR system you're using, you will always think about this to control for just reducing that. That'll be intrinsic error in your measurement always. Based on geometric error.
Spoken like a true physicist. Exactly. That's great way to put it. Reflection, refraction, all that is important to read. For whoever's scratching their head with that, read up on it. It makes a huge difference in how accurate that data is going to be.
Mm-hmm. Yep. General rule of thumb for you. So for me, I typically 60-degree field of view. I'm gonna I'll cut it at that, if I'm doing anything.
Yeah, it all depends on the vegetation all across the site. 60, sure. I may push it up to 80 if it's an open site.
Yeah.
But I won't like that too much on the east side of our project with the trees. So.
Or you open it up because you accidentally flew too low and now it cut off some things.
Yeah.
We've all been there before.
We've all been there.
There was another question that popped up. Shooting. Yeah, there we go. Control points with GPS or with the total station. If you can do it with a total station, that's awesome.
Mm-hmm.
Total station you're going to get repeatable values very easily. You're going to have real good elevations compared to GPS, so your data should adjust a lot better, and you're going to see a lot better results. But it's not always practical when you have like a 100-acre site getting across it.
Right.
What I've done in the past, even though I've set my points with GPS, I may set up a total station and use that for some of my check shots. I may use that and go down a line across our project or something using a total station. It's a great way to check it because those are actually more accurate than how you're putting your control points down typically.
Mm-hmm.
Awesome.
Is there a situation when you would use photogrammetry over LiDAR in respect to a topographical survey?
So a lot of people think LiDAR and that's the only thing you want to use for topographical work. No.
Yeah.
If it's a hard surface, I'm usually using the photogrammetry. Parking lots, some of the roadway stuff, around buildings sometimes. The photogrammetry will usually work out quite a bit better for you. And you usually need photogrammetry if you're ever going to actually pull actual brake lines out of your LiDAR data. It's good to have that because it's going to help you see a lot more than what you'd see with the intensity.
Mm-hmm. Do you ever encounter problems using a CORS network base station for RINEX files?
If the core station isn't on.
Yes, so you have to be careful. When you're using a CORS station, you need to look at the frequency. How often is it recording?
Mm-hmm.
You want 1 second. You don't want 5 seconds or 10 seconds, 15 seconds, whatever, because you're actually seeing your trajectory. It's going along, and all of a sudden it skips up or something, and then goes and skips somewhere else.
Mm-hmm.
You want that 1 second interval, and the base can be too far away. Mm-hmm. So again, ASPRS actually I think has that standard out, but some people say about 20 kilometers max. But depending on the system you're using, that IMU you have in there and everything, you might want your baseline to actually be a little bit closer.
Mm-hmm. Yeah, I think for me 20 kilometers is kind of a max. I still go by this 2 parts in a million.
Yeah.
So every 10 kilometers you're losing 2 centimeters.
Yeah.
So 20 kilometers you'll just.
I usually keep it at 8 kilometers if I can.
8 kilometers.
Keep it within a couple like 2 miles, 2-3 miles. So
I think that's pretty solid. What is the optimum ceiling when shooting photogrammetry as well?
Oh man, we're getting into it.
It depends. Harrison, you'll fly at 40,000 feet, right?
It's all a matter of resolution.
I mean, satellites much higher than that.
Yeah.
It's all a matter of the image resolution you need. So that 1 to 2 horizontal, 2 to 3 vertical, that translates the photogrammetry as well, dealing with your ground sample distance. So the resolution you're flying at, you're flying a P1 and an M300. It's real easy to do like a 1/2 inch image resolution. So then horizontally, you're going to be within 1 inch typically, and vertically you could be 2 inches, at worst, hopefully, if it's all done well. So, that's at the discretion of projects, accuracy requirements, something to, you need to know what are you hoping to get out of that project that you're about to go out and collect.
Totally. I think just summing up, it really depends on the sensor you have. So the drone, which camera it has and what lens it has, if there's an interchangeable lens.
Yeah.
Right. So you can, even that P1, you can put on a 50, whatever, I think they have a 50 millimeter lens and you can fly much higher, but then, you just, so it really depends. What is the difference between checkpoints and GCPs? Do they both have known points, or is one just placed somewhere along the flight area?
So if I'm understanding this right, so GCPs, you're going to strategically lay out evenly across your site because that's how you're going to correct your data. and everything ensure accuracy. Your checkpoints are also spread out across the site. There's going to be a lot more of them. Yes, there's known coordinates, but you're checking your data at that known coordinate. So, at a 10,000 northing and easting, you want to make sure your elevation matches the 100 elevation that you're reading with your GPS.
Mm-hmm.
So I'd say essentially, like, technically you could just do a bunch of aerial targets and capture a bunch of data, and then in post to say, I'm going to use these 5 as my GCPs, and I'll use
Absolutely.
these 30.
I do that a lot too. Yeah.
Yeah.
You want to be able to tell, like, I want my GCP to be the best. Like, if I got to decide, I want to decide after.
So, I mean, but technically speaking, when the guys are out there physically on the ground getting data, there is no difference. Like, that it's still capturing data with the same GPS or the same total station.
Yeah. The only difference is for my ground control points, I like to go back a couple hours later and observe them again. Satellites change over time, so different arrangement of satellites. You average those shots with the original ones, and it should tighten up your accuracy of your GCPs.
So you usually shoot them twice, or 3 times if you're out there all day.
I have them do 3 30-second observations, and then they'll come back and do 3 more 30-second observations. So then when I look at it to post-process, I have 6 observations I can look at and see the residuals of, and if we need to turn 1 or 2 off, we can.
Okay.
That's awesome. I'm interested in setting up multiple ROCK base stations at remote archaeological sites to get the most precise site measurements, alignments, etc. Well, Seth doesn't have one yet, but hopefully he will. Yeah, sounds awesome. I think that's, I don't know if there's, what's the exact question here?
I guess, would it work?
Would it work? Yes, it would work. I mean, essentially all the ROCK base is, it's just a geodetic grade GPS receiver. It's just a high accuracy triple band antenna, and it's just logging data. And then what we're doing on the back end is we validate that the system isn't moving. And then we'll take a 24-hour observation. And here, if you're inside the CONUS, so the United States, I think it works in Alaska as well, we use Opus to perform that precise point location with a 24-hour observation. And if you're outside outside the US, we use NRCan. And so actually NRCan works really good. It's amazing. So that works around like the rest of the world. And so with that, we're able to get the residuals of the location of the antenna down to about 1 millimeter, just plus or minus a few. So it's all half centimeter-ish. I'd say at the worst. I mean, this is kind of the end of the day, like what you're going to look at. And then so everything would be referenced from that location. So, and like Seth said, if you're doing the LiDAR, he wants to do an 8-kilometer baseline. I think, that's the distance from that GPS receiver to where you're out in the rover. And we were discussing loosely, some people say 20 kilometers is kind of the limit, so there's a lot of different, nomenclatures of how far you can go. And it really depends on the space weather at the end of the day.
And where you're at too. I mean, if you're in the middle of 2 giant mountains, it's going to work in the valley, and that's it. And if you're out in Western Australia, you may get lots of distance.
Well, no, because the baseline doesn't matter in this case because you're.
I was talking about the baseline, just like how far you are.
But you're getting it all over cell signal, so
right.
It should be just a radii no matter what. And then the reason that these numbers change, why Seth and I and person B and C and D will all say different numbers. Actually, these numbers change every day and constantly. That's why Seth is out there doing 3 30-second observations. Then he comes back and does 3 more because there's parameters that change on the physical geometry of the satellite constellation. This is your dilution of precision, your DOP. So that is a big factor. So that's the geometric configuration of where the satellites are oriented. And then the other huge thing that plays a big role today, because DOPs are, for the most part, pretty good. I mean, we have so many freaking satellites in the sky. Your DOP is almost always going to be fine. But the big thing is that we have this ionosphere weather. And so there's this thing, your electron density up in the upper atmosphere in the ionosphere, that causes delays of the signal. And essentially, we generalize this whole topic. We just say space weather. There's space weather up there. And, if it's storming up there, then you're going to have to be really close to that baseline. But if it's blue skies and sunny up there, well, your baselines can be really long out to these, 20, 30 kilometers, fine. So anyways, in the future, just total nerd thing. I really want to because what the ROCK Cores network is doing is we're measuring space weather, and we're building up essentially like a radar map of space weather in order to monitor these delays in order to then send corrections out to you at the rover. So that's what you're getting in this RTCM3 traffic. I want to actually make a real something that looks like a radar, so you can actually see the space weather moving across the country. That could be so cool. And I would love to actually mathematically show the radius from a base station of acceptable data and have that dynamically change based on.
You can probably show it as a heat map.
Yeah.
Yeah.
So I would love to do that.
Having some college flashbacks to my senior year here. Solar flares and
right.
I get emails all the time warning about solar flares, and South Florida and stuff like that. Careful using your GPS at these times and all, and it can matter.
Seth, is this the classic surveyor's way of getting out of work?
Solar flares today, guys.
We got high solar flare activity. I can't do anything.
Now then you got to bust out the total station and your day just
back 10 years ago, before Galileo was going and Baidu wasn't a thing. It was afternoons where I was at in Pennsylvania. Afternoons. GPS was not very good, guys. We got to either wrap it up or pull out the total station.
Yeah. Looks like we got one more question, and then we're going to have a bunch more on the Facebook and YouTube that we'll go back and answer on there.
Yeah, could you use a ROCK base as an ultimate GCP if you set it up on site a few days ahead of flying the mission? So if it's over the top of a known point, something that you can see, then absolutely.
Yeah.
And this is actually the notion of, people set up base stations at job sites, and they'll let it sit there the entire time. They're doing all the earthwork, and then they're going to keep it there throughout the whole project life cycle. They'll just keep that local base station there. And that's very common.
So we talked about using base rover and total stations for GCPs, but if you can collect static on them, it's awesome. It's awesome to do, and you get great results. You're going to get RMSC, a centimeter, or maybe even better, real high reliability. So perfect world, academia. I teach classes at Penn State too.
Awesome.
Before, but they'll they have all the time in the world as students who make them do static observations for their GCPs because what's 2 hours?
What's static for them? Yeah, I go all day. Awesome, guys. Well, Seth, hey, it's been awesome having you on here. I think I really appreciate it myself. I learned something. I know everyone else who listened to you today learned a lot. So
I'm hoping we can do a part 2 here. We just brushed the surface on some of this stuff and missed a few other things. So
if you're not careful, Seth, you'll just have to be on every show.
I mean, if you need me to be a regular or something, I guess. But
that'd be great. I think everyone would like it too.
Yeah,
great. We'll just call in the surveyor or something.
Call in the surveyor. Yeah, I love it.
Surveyor, ask me anything.
Would you like to phone a surveyor?
Yeah, phone a surveyor. All right, yeah, it's $20 a minute.
Is this your final answer?
Yeah. Seth's out here making drone money, guys.
Seth's out here making drone money. With that, guys, we have another episode on April 11th. That is the next episode of Drone Money, and I hope you guys enjoyed the episode. Remember, subscribe, ask more questions. We'll answer them after the podcast, and we'll see you here next time here on the Drone Money Podcast. Bye.
Yeah.
See ya.